Today's show is sponsored by Okta, the leading independent identity solution. Okta provides best-in-class authorization so your customers and workforce can safely access what they need most right when they need it from anywhere. Organizations around the world trust Okta's Identity Cloud to sign in, authorize, and manage users, whether it's employees, contractors, partners, or customers. And with Okta's developer tools, you'll never have to build authentication again. Our customizable code blocks are flexible and future-proof with easy-to-use APIs and SDKs, so you can do less coding and more shipping. Okta is dedicated to building the most reliable, neutral identity platform because it means protecting more than a login. Identity is protecting people, their ideas, their work, their brilliance. It's protecting your future with confidence. Learn more at okta.com. That's OKTA.com.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Going to jump right into the news this week as for the first week of June here. For our first story, actually a longtime friend of the show and really happy for them, A Cloud Guru. I'm going to get nostalgic for just a second. A Cloud Guru came on the show very early on and really to originally talk about serverless and the serverless platform they set up, and were very big advocates within the serverless community, and then of course grew their training business and really were very successful at it. Fantastic folks over there, great company to work with. And now they've been acquired. Plural Insight announced an intention to acquire A Cloud Guru, going to close later this year. But this is all part of the larger skills gap that is happening in our industry as more and more projects and workloads move to the cloud. Where are the skills to operate that, to set up all the tools, make sure all the data flows where it should, and of course, all the certifications that tend to go with that and the job market. So it's really good to see this happen, and certainly congratulations to A Cloud Guru and everyone there. We certainly wish them the best. For our second article this week, we're going to talk about Snowflake. Snowflake, they just keep getting bigger and bigger. Super successful. IPO'd last year and doing very well quarter over quarter from a product revenue standpoint. And they've announced their next step. They are announcing a data marketplace and what they're calling powered collaborations. So first of all, let's take each of those in turn. What is a data marketplace? Well, this ability to basically purchase data sets and use anonymized data sets to improve solutions. Snowflake got its start as data warehousing. So now how can I take advantage of some of that data and they as a company monetize some of the data? And we didn't know this necessarily was coming, but we did know as Snowflake, of course, as they're public, they want to continue to grow their business. They want to offer new things out there. So this was another offering, another tool in the toolbox, if you will. And the second part of that is powered collaborations. They use for instance, in their Snowpark, support for Java and Scala, and built specifically for data engineers, data scientists, developers in mind. So really continuing to attack that core audience that made them successful. And we have seen this with other data management platforms that are out there in the industry. As you get all of this data, now what can you do with it and how can you help your customers go faster? So very fascinating to see this and really excited where this is going to be going in the future. For our third news article this week, it's all about Confluent. Confluent, of course, makers of Kafka. And we actually will link out to the Clouded Judgment Substack. First of all, if you're not subscribed to Clouded Judgment Substack, we recommend it. All about SaaS offerings and S1s and really kind of digging in deep and offering an analysis on them as well. So they have, of course, Confluent filed the S1, and S1s are super fascinating for us in our industry because it's that first time you really get that peek behind the curtain of how big are they? How many customers do they have? How do they see their market? How are they planning to make money? And of course, this is starting to drum up excitement for the eventual IPO as well. So if this is of interest to you, go look at Clouded Judgment and their kind of, I'll call it a review, if you will, of the S1 statement. Very, very fascinating read. And here at the Cloudcast in particular, we are trying to learn the as a service market and the metrics and what really matters as a lot of our industry start to make this transition into the as a service and subscription-based models. So very fascinating read, and I highly suggest everyone go take a look. And now for our last news article of the week. Blackstone, private equity firm, has gone into an agreement to purchase IDG for $1.3 million. IDG, of course, and IDC as part of it, been around for a long time. Actually, I didn't know this, but they were around for over 55 years. I didn't know they've been around for that long. But what do they specialize in? Market intelligence, specifically around the technology industry. Lots and lots of analysts there really looking at and putting together reports for numbers. And IDG obviously going into a new phase of their life as a company. As I mentioned, 55 years old. So going into the next stage and hopefully growth for them as well. And so congratulations to both IDG and Blackstone. And so with that, we're going to move into our main segment this week. Right after the break, we're going to be talking about building private 5G networks with Rob Parsons.
Today's show is brought to you by CBT Nuggets. You know how much we value ongoing education on the Cloudcast. And CBT Nuggets is exactly what Aaron and I wish we had when we were trying to get our certification early in our careers. CBT Nuggets is all about bringing a personalized touch to learning about cloud computing, virtualization, networking, DevOps, and much, much more. Whether it's their hands-on labs with personalized coaching or the online chat functions that come up with every instructor-led course, CBT Nuggets' team of experts is always there to help you get the most from your training and your path to certification. You can check it all out at cbtnuggets.com/cloudcast and sign up for a free trial. You get access to the full catalog of great training, including virtual labs, quizzes, and other premium features completely free for the first 7 days. That's cbtnuggets.com/cloudcast. Today's show is sponsored by Datadog, a monitoring and analytics platform for cloud scale infrastructure and applications. Datadog provides dashboarding, alerting, application performance monitoring, and log management in one tightly integrated platform, so you can get end-to-end visibility quickly. Be proactive with your monitoring strategy and catch issues before your clients are impacted. Start managing the overall health of your environment with a free Datadog trial. Go to datadog.com/cloudcast for the free trial. That's datadog.com/cloudcast. And we're back. And folks, one of the things that we've hit on a few times, as we start to talk about edge computing and edge computing becomes more and more of a topic in our industry is we realize a couple of different things. Number one, there are a lot of different sort of edges, if you will. Some people look at them as sort of small computing. Other people look at them as, putting technology in places that previously was just very, very difficult to reach and to, deliver applications. And one of the concepts that's been coming up quite a bit lately that we've been hearing about, but we haven't had a chance to dig into, is this idea of sort of private LTE, private 5G. How do we sort of mix together some private sort of cell technologies with Wi-Fi technologies? And we really kind of wanted to dig into that a little bit today because as more and more people are putting technology in new places, that's something that we've got to be able to do. We got to be able to get to where they are and deliver applications. So very excited to have Rob Parsons, who is Practice Director for Network and Integrated Securities at Insight Enterprises. Rob, welcome to the show. Excited to have you on.
Excited to be here. Thank you.
So we're going to talk today a little bit about this concept of Citizens Broadband Radio Services, or CBRS. But before we dive into that, I want to get a little bit of your background and then ultimately, how you kind of came around to having this as part of your focus areas.
Yeah, absolutely. So personally, I spent a number of years in consulting, helping very large organizations to navigate solving business problems with technology. So um, during that time in the field consulting, I actually became very specialized in wireless, and spent a lot of time doing Cisco networking and Cisco wireless, and achieved some expert level certifications in the wireless space. So that's always been a great point of passion for me. And CBRS is just a narrow departure from that. So really excited to be able to come on here and talk about that with you today. And I think you set it up really well, Brian, talking about, really the multiple edges. It's something that a modern edge as we look at environments today. And when I look at what we consider to be the modern edge, the truth is that there are so many different ways to connect that we have to be able to provide a common set of experiences to users who connect across all of the platforms, whether it's an Ethernet connection at their desk, it's a Wi-Fi connection, in an office or at a coffee shop, or if it's a cellular connection out and about. And then now talking about CBRS and what that brings us from really a private cellular perspective, to be able to connect all of our users in whatever industry it may be, but to do so securely. So I look at that modern edge in a few different ways. How do we connect? And then how do we optimize that connectivity, whether it's with a different radio to be able to manage a throughput requirement for an app, or manage a security requirement. And then ultimately, at the end of the day, how do we, pull all that together and make sure it's absolutely secure in the way that we're transferring data? So I think you really started it off well with that modern edge kind of angle on where we have to go here.
Yeah, very, very cool. So I want to start with some basics because we've mentioned this acronym CBRS, but for a lot of people, they're going, I don't know what that is. Maybe I don't necessarily live in that space. So give us some basics. What is the technology? I know it sometimes gets mentioned as sort of private wireless or private LTE, but kind of give us some basics of what is it and sort of, what do we need to know the basics of that technology?
Yeah, so CBRS is interesting. It runs in the 3.5 to 3.7 gigahertz range. So for comparison's sake, common Wi-Fi that we all have at home runs in either the 2.4 gigahertz or 5 gigahertz range. So it's somewhere in the middle from an RF perspective. And then again, in comparison, cellular is going to run anywhere from 900 megahertz on up. And CBRS is really cool because first off, it's a newer technology. It's been ratified more recently. So it's both available to the public, but also there were some grants of frequency spectrum that were allocated to some bigger organizations that were able to buy that up when it was first released. So CBRS is great when we look at the available spectrum that's available for public use, in that it's not busy. If you were to be in a city today and open up any sort of Wi-Fi scanner and look at the amount of Wi-Fi that you see in the 2.4 gigahertz range or the 5 gigahertz range, you're going to notice it's incredibly busy. And wireless in general is kind of a friendly protocol. So when someone is talking on a given frequency, a device is talking, it's common practice for all other devices around to stop and wait for that device to end. So CBRS presents us with new available frequencies that are not as saturated as the traditional Wi-Fi spectrum. And with that, we're able to get high throughput availability for the devices that exist there. So really excited about what that means. We've done some really cool stuff already for some public sector organizations, really being able to to bridge the digital divide and be able to offer connectivity in a widespread basis for, kids that are trying to go to school in the pandemic and they need to do so remotely, or other folks that need to work from home in that type of situation. But there's obviously use cases in the private sector too, because the CBRS technology allows us to cover a much greater physical area with less infrastructure. So whereas with a Wi-Fi access point, you might only get 100 yards of coverage in an outdoor type of cell, you're going to get a much greater physical footprint out of CBRS and still be able to maintain a quality throughput. So that's really a big deal, to be able to deploy less infrastructure and be able to get a quality output from it.
Okay. Yeah, no, and that makes a ton of sense. I know, way back in the day, I used to work on some of the earlier Wi-Fi and outdoor Wi-Fi stuff. And there was always this trade-off between, like you said, how much throughput you can get. So maybe it was 10 meg or 100 meg. And then, how far you could go. And the further away you got, the less the signal would propagate, and hence you'd get less throughput, or, less devices could connect. I'm curious, we all think about our cell phones. They come with a built-in radio that connects us to, AT&T or Verizon or whatever, 5G, LTE. Comes with a Wi-Fi radio. To use this CBRS, because it, like you said, it does provide this sort of nice sweet spot of, less congestion, higher bandwidth. Like, do I need special technology? Is it built into stuff today? Like, how readily available could this be for, all sorts of applications?
Yeah, you definitely need an endpoint that supports the CBRS frequencies, and the cell phone manufacturers are starting to bring it in. So I think there are a couple out there that already have the chipset supporting it, and we expect more to come as well. So certainly the endpoint is a critical component to it. But another thing that we see with CBRS that is really interesting is the security side of things. So much like cellular, CBRS devices are going to utilize a SIM card. And that SIM card provides a physical layer of security for that device to access the radio network, sometimes referred to as a RAN of a CBRS network. And so that gives you that more absolute security of this device is physically authorized to get onto this network. With Wi-Fi networks today, while they are secure, we have a more software-defined security mechanism of either a pre-shared key or a multi-faceted handshake that happens to be able to authenticate and get onto those networks. And so the physical SIM card component does bring an element of security to CBRS networks that we don't get with Wi-Fi.
Nice. Yeah, because Wi-Fi, you always had the challenge of these long SSIDs, and was it using this encryption or that encryption? That's nice. You sort of take that out of the hands of people making mistakes of it or having to update it. So that's very, very cool. Let's talk a little bit about use cases. You mentioned, obviously, like for kids at schools and cities, the ability to get them onto the internet and kind of do that in sort of broader areas or rural areas makes a ton of sense. Like, what are some of the more other types of use cases you're seeing, even as we're in early stages of this, things that people are either doing well or even exploring?
Yeah, so I obviously still new, so there's a lot of exploration going on. 100% number of use cases in the digital divide, getting the kids to school, getting people to work remotely over the last year. When we start talking about private industry, we're talking with organizations around farming and agriculture, how you might leverage the CBRS radios to cover large physical areas in the farming industry. We've had talks with other government organizations that are looking at it from a military perspective. We're looking at large manufacturing and shipping and distribution both. So manufacturing, if you've got any sort of product that may need an update in a physical in an outdoor lot or an outdoor space. Obviously, Wi-Fi is only going to go so far, and as you pointed out, the limited bandwidth capability. The further you go, the lower the rate. So CBRS helped us to cover a broader area with a higher rate. So thinking about anywhere that I might be producing a lot of product, but then gets a final software update before it goes out the door. So anything that's intelligent or enabled with some sort of computer interface, this is obviously a huge game changer to be able to get those updates just in time before product goes out the door. Thinking about manufacturing, shipping, and distribution, how do you cover the large trucking and distribution facilities? So there are warehouses that are literally half a mile long, and a lot of times that takes a lot of wireless access points to hit all of the trucks that are outside loading up. But ultimately, you might want to transfer data to. So CBRS allows us to cover that with a much lower footprint. And then we've also had some conversations thinking more of the waterways, thinking about the ports and dock systems of where you might have a lot of attenuation objects. So things like metal, concrete, fencing, all are hard on wireless technologies in general. But I'll tell you, it basically, those type of things completely knock out the use of 5 gigahertz. So 5 gigahertz Wi-Fi in that type of hardened environment, it's not going to be something that's going to be incredibly effective. 2.4 gigahertz will work, but it's incredibly saturated. So 3.5 to 3.7 gigahertz with CBRS gives us a nice kind of middle ground where you'll get some of the penetrative qualities of the lower frequencies, but also be able to maintain some of the higher throughputs. And so a lot of different private industry use cases in really the early stage of discovery. And I think a lot of it does also tie in with that modern edge that we talked about of, how do you get the connection? Because you're going to have a multitude of connections in those environments. You're going to have Ethernet, you're going to have Wi-Fi, you're going to have CBRS, you're going to have cellular, all of those devices that connect to those networks in the various areas as needed. The users that consume don't really care what network they're connected to. They care that they're connected. They care that they're connected to the application that they need. They're able to do the work that they need to do. And at the end of the day, we bring all of that back. And sometimes, we're going to do some compute closer to the edge. Sometimes we're going to transfer it back to the cloud. Whatever is really necessary there, we've got an incredible amount of flexibility. I think the flexibility is really the key story in the modern edge and how we take it and extend it to these different industries.
Yeah, no, and it makes a ton of sense. I mean, we have, just if you take that, mobile, transportation use case, whether it's a plane, train, automobile, boat, whatever it might be, like there is so much more information, there's so much more essentially IT on those things, whether it's sensors, collecting data, interacting with, marketplaces, interacting with rail, or, weather, all sorts of stuff. So you think about that and the ability to start offloading that data further from the actual port at a higher bandwidth. You think about your plane coming in, that plane has a ton of information. It wants to get off the plane before the next plane takes off. And, you just, it's one of those situations where, just having the ability to say, we have more bandwidth and we have better CPUs to just do things faster. There's always sort of an order of magnitude effects that happens out of that. So that's very, very cool. I'm curious, we don't have to get into tons of detail because obviously audio podcasts are an audio medium. So sometimes it's hard to see things, but from a design perspective, you've designed earlier systems, probably both indoor and outdoor Wi-Fi and so forth. Like, what are some of the different considerations you have to think about for CBRS? Is it mostly, radio placement? Is there, are there new sort of considerations that you didn't have in previous generations of wireless that are now, a big issue to think about?
Yeah. So continuing kind of the RF strategy, and this applies to, legacy systems like Wi-Fi as well. but where's your where's your RF going to penetrate? What kind of range and rate are you going to get out of it? The endpoint is a key design consideration. So, we talked about cellular type of endpoints, the phones that are out there, but you also have your more pointed industry endpoints as well. So, for example, like a cradle point type that might be used to connect to the network, but then provide an entire other network on the other side of it, as a backhaul modem. So that's certainly something that's a consideration. Are you using pervasively all of those type of devices to connect? Like, I would imagine if we were using the shipping example, if we were building a CBRS network, I would put something like that endpoint on each ship, and then that provides the connectivity to the rest of the devices on that ship. And it's just a single device that's connecting back, and that gives us a lot more clarity in the spectrum as well, by reducing the number of endpoints, and also allows us to use a higher power device. Certainly the considerations for how SIM cards are distributed and connected, much more like a cellular type network. So those considerations come to mind. And then last, and probably most importantly, is the evolved packet core. So on the infrastructure side of a CBRS network, how do you translate that RF from the radio network back onto an Ethernet frame, onto an IP network, and then obviously be able to transmit that data from there and, switch it, route it, send it to the cloud, whatever you need to do once that data hits an infrastructure aggregation point. And that packet core is crucial to every CBRS deployment.
Yeah. I want to sort of shift gears a little bit and talk a little bit about the applications. One of the things about, whether it's Ethernet or, Wi-Fi is you don't really have to change the applications. Like, applications aren't really built to say, hey, I know what the underlying network is. Like, the network protocols kind of take care of stuff and backoffs and failures. Like, is there anything that applications kind of have to be CBRS aware? Like, is there an ecosystem that's sort of building things that are, kind of specific to this deployment? Or is it more just, hey, now that there's bandwidth in places or higher speed bandwidth, the sort of verticals will build their own things just because, hey, there's new opportunities there. How does that tend to work?
Well, I think there's resiliency that should be built into applications that are designed to run over any sort of wireless mechanism.
Sure.
And this would apply to Wi-Fi, the same as anything that runs over cellular as well. And that's really just, you need to have an application that expects that there may be a moment in time where traffic may not flow, and it may need to wait and be able to wait gracefully for that connection to come back online to be able to transmit whatever data it needs to, whether it's a send or a receive or whatnot. So yeah, I think that at the end of the day, the application shouldn't care. Going back to the modern edge conversation, the application doesn't care about what the transport mechanism is, but it does need to have that flexibility and resiliency to be able to handle the things that do happen in over-the-air networks, the momentary interference, in the case of Wi-Fi, the airport radar that takes out certain channels for a period of time, things like that. You have to be able to be flexible. And the fact is, most applications are, and most application designers plan for that. Where you get into some true sensitivity is real-time media. So when you're talking about voice and video,
Sure.
That's where the timing becomes absolutely critical, because if you don't deliver the packets on time, then you get buffering and glitches and jitter and things like that are distinguishable to the end user.
Right. Yeah, sure. Absolutely. Let me ask you one last question. This has been really, really interesting and very helpful. So we're appreciative. For anybody who's, a networking professional or sort of, has experience, like you said, Wi-Fi certified and so forth, How much of a learning curve do you find this is? Is it sort of just incremental, or do you find it's been sort of a steep learning curve to pick up kind of the nuances that you need to know for CBRS, or kind of the normal part of the learning that infrastructure professionals do all the time?
I'd give it kind of a moderate rating as far as the learning curve. So if you're really well versed in Wi-Fi, there's certainly an element. All of the RF stuff tends to carry over. It's a different frequency with some slightly different properties, but most of that carries over. The Evolve packet core is something new from a network or Wi-Fi professional perspective. So that's something that needs a little bit more thought and evaluation, and the SIM card end of things. So obviously a cellular professional would come in and be very well versed in that type of SIM card distribution and programming and everything that goes into that. That's not something that we're traditionally accustomed to on the network side of the house. So that has a little bit of a learning curve to it as well. Yes, there's a learning curve. It's nothing incredibly scary, but I would certainly encourage everyone to go dig in. And the number of resources are growing out there. This is still something that's new. So the resources grow every day. If there's not something here today, it'll probably be there tomorrow. And if you want to learn in this space, just keep pushing. There's a lot of opportunity here.
Yeah, very, very cool. Good stuff. It's, we always like to say, there may not necessarily be completely brand new ideas, but anytime that you can unlock either new bandwidth or new CPU into areas that didn't have it before, you really start to unlock some really interesting application potential and typically new business ideas. So it's always fun for us to kind of dig into new areas and like we started the show, really kind of establishing what that edge looked like. And I think you did an awesome job kind of going into, like you said, this is sort of the modern edge. This is the evolution of the edge. And there's a lot of opportunities out there. Rob, I want to thank you so much for the time today. It's been great having you on. It's been great being able to pick your brain for a little while, just to learn about this new space. So folks, with that, we're going to wrap it up. We want to thank you as always for listening. Thanks for telling a friend, and thanks for giving us feedback in all the ways that you rate the show. So with that, I'm going to wrap it up for myself and for Aaron. We want to thank Rob again, and we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.